Hi everyone, myself P.ANUHYA studying B.Pharm second year in MAHARAJAH'S College of Pharmacy. Today I am going to give a seminar on the topic chemical sterilization. Chemical sterilization is a type of the sterilization. Sterilization is a process on which a surface nor a medium is free from all the microorganisms either in a vegetative nor a spore state. Coming to the gaseous sterilization. And the sterilization is divided into three types: the physical, chemical, and the mechanical. Coming to the chemical, the gaseous sterilization, it's of four types: disinfectant, ethyl oxide, formaldehyde, and beta propylolactone. Coming to the disinfectant, it is the chemicals agents most commonly used were the disinfectants and antiseptics. Coming to the example, phenol, alcohols, aldehydes, and dyes. The mode of action over here is the cell protein and also the inactivation of the enzymes and also the leakage of amino acids. The action may be bactericidal nor a bacteriostatic. Coming to the application is the clinical oral thermometers. Coming to the second type, it's ethyl oxide. Ethyl oxide is a liquid inflammable exposure when it is a liquid inflammable when exposed when mixed with the air, and also when mixed with the CO2 nor as a fluorinated hydrocarbons it makes non-flammable. Here there is a table representing the concentration and the exposure time. 44 concentration it's 24 hours, and 88 concentration it's 10 hours, 442 concentration it is 4 hours, and 884 concentrations 2 hours. Coming to the mode of action over here is action of the ethyl oxide is due to its power of alkylating the amino carboxylic hydroxy and sulfur groups, enzymes, and also the protein molecules. It reacts with both DNA and or also RNA. Coming to the application over here is it's a powerful sterilizing agent for the heat and moisture sensitive materials. And also ethyl oxide is used for the sterilization of the medical biological preparations, cat gut, plastic equipments, antibiotics, plaster bandages, culture media, disposable foodstuffs, disposable syringes, hypodermic needles, prepacked materials, hospital bleedings, foodstuffs, heavy equipments, books, clothing, and soil, etc. are sterilized by this method. And now let's discuss about the advantages and the disadvantages. Coming to the advantages, it's suitable for the thermoreliable substance and does not damage the moisture sensitive substance and also equipment only because a low humidity is required. And also it is used for the pre-packed articles because of high penetrating power of ethyl oxide, and also it is a highly reactive compound. Coming to the disadvantages, it is a slow, long process and desorption periods are necessary and cannot be used during the emergency. The running costs were high, and also the ethyl oxide is inflammable. Coming to the next one, it is formaldehyde. Like ethyl oxide, it is an alkylating agent but in generally inferior for use as a sterilizing agent because formaldehyde has a pure penetrating power and is readily activated by the organic material. And also the high concentrations are difficult to maintain in the atmospheric because it tends to deposit in the form of solid polymers on contact with the cool surfaces. And also HCHO in aqueous solution is known as a formalin and paraformaldehyde used in sterilized enclosed area. Coming to the mode of action over here, it combines with the vital organic nitrogen compounds such as the proteins and nucleic acids. And also the conditions over here input concentration must be 2 grams per liter of HCHO in subatmospheric stream, whereas the temperature is of 90 degrees Celsius and exposure time is 3 hours. The application over here is it's used as a disinfection and sterilization of enclosed areas such as operation theaters, hospital rooms, aseptic area, microbiology lab. Over here the disadvantages, it has a low penetrability, it cannot penetrate polymeric packaging, polymerize to inactivate forms on the surface of low exposure temperature, and can fall in active concentration and cannot sterilize narrow lumen. Coming to the solution of the above problems by reducing the size of the load, increasing the exposure temperature. And the next type, it's beta propylolactone. Beta propylolactone is a heterocyclic ring compound, is a colorless liquid at room temperature with high boiling point of 155 degrees Celsius, and it is capable of killing all the microorganisms, and it is very active against virus. The bactericidal over here is used in concentration of 2 to 5 milligram per liter, and the low power of penetration which causes irritation and the carcinogenic properties and not recommended for the pharmaceutical industry. Thank you.